Welcome back, lab partner. We are ready. We are ready. Here we go. Okay, so I've taken some of the hot water and we put it into the graduated cylinder. Meniscus reading, remember that? We are at 99. I'm going to go 99.2. No, I'm going 0.3. I'm going 99.3 on that. So that is the mass of the hot water. Because remember, 1 milliliter goes 1 gram. Just write that down in your paper. Okay, come on, lab partner, help me out. 99.3 grams of the hot water. Now we need the temperature of the hot water. So put the temperature probe in, get the hot water temperature. It's reading on this bed, Larry. Oh, I don't think I'm gonna be able to bring it all the way over to you. You're just gonna have to trust me on this one, lab partner. Maybe. Okay, how we doing? I don't know if you can see that. Probably not. But it does say 43.4. Whoop, don't tip over the water. 43. I'm not a good lab partner, by the way, just letting you know. 43.4 degrees Celsius, of course. So 43.4. Let's write that down for the temperature of the hot water. 43.4 degrees Celsius. All right, lab partner, here we go. We're going to pour this into the calorimeter. So pour that in. As much out of there as we can. We have a piece of ice, which has been sitting here for a couple of minutes, so it's getting a little melty. So I'm going to dry it off. That's my dry ice joke. Get it? Dry ice. I got dry ice. Okay. We're going to now. I'm going to put this in. The top on. Put the temperature probe in. 1 ice cube. Now, this 1 ice cube. Okay, we want to get this in there, and then we're going to put the temperature probe in. I'm actually going to use the temperature probe as a mixing device. The water temperature is going down. I can't show that to you as we speak. Now what I want to do is I want to stop taking temperatures as soon as that ice melts. And mix it. We got to mix the water because the cold water is what the ice cube turns into. And that cold water, okay, still have that ice cube there. Mixing. That was a big ice cube. Maybe I should use more water. We'll see. It takes about how long it takes for this to melt. The longer it takes to melt, the more error that we have. So we don't want a lot of error. Let's see how this turns out. Okay, come on, ice cube. Oh, it's almost melted. It's almost melted. I think we're going to be okay. Of course, I do have to let some ambient air in as we mix. Okay, we're at 22.0, 21.9, 21.8, 20.7, 21.6, 21.5, 21.4. Still going down. So we're mixing this. It's beginning to slow a little bit. Okay, let's see if the ice is melted. Not quite. Oh, usually we want it to melt in under a minute. 20.0. Okay, still mixing it with the ice gone. Not quite. It's just a smidgen left. Smidgen. That's small, by the way. Okay, it's slowing down. It's 18.8, 18.7. It seems to have stuck at 18.7. I think we've got the equilibrium temperature, but let's check and make sure we've melted the ice. We have melted the ice. I'm going to do a last minute mixing and get a temperature reading, and then we're done. Now at this point, we do have to take the top off at times. 18.5 seems to be where we stabilized. So yeah, 18.5. So 18.5 degrees is our final temperature. It's called the equilibrium temperature. So temperature of hot water after the ice is added is it's still at 18.5. You just have to trust me on that level. No, you know, I can move you. Okay. There, you see? I don't know if you can or not, but I'll move you around until you can. 18.5, okay? So you can trust me, lab partner. I'm building trust. We're building trust. You know, you have to be good lab partners, we have to trust each other. Okay? So 18.5 degrees is the temperature of the hot water after we added the ice. And it became an equilibrium temperature at that point. Now, what I mean by equilibrium, we'll explain when we do the video on how this all works. Getting the data is pretty quick. It is pretty quick to get the data. Doing the lab takes a little longer to do the calculations, but this is a very quick lab to do. And at this point now we're done with this first trial. Let's go through and do some of the filling in of our data table. Temperature of the hot water, did that temperature difference of the hot water. Now the hot water was at 43.4. And then we subtracted from 18, we subtract 18.5 from it because that's what the hot water did. It was really hot water and then went, as the ice cube was melting, getting colder and colder, of course, because the ice cube was cold. And we get this final temperature of the hot water. And then, so we went from 43.5 and we're going to subtract 18.5. You do the math on that, let's see, 43, 25, 18, 28, 38, 39, 40, 41, 42, 43, that would be 25, but one less than that, so 24.9. Did I do my math correctly, left partner? Help me out there. I think I did, but you want to check it. So 24.9 degrees is the difference of the hot water as it went from 43.4 to 18.5. So we'll just add this up and make sure. 9 minus 14, carry 1 is 3. 1, 2, 3. Lab partner, we are good. We are good with our math. We don't need no calculator. Okay, temperature difference of the cold water. What do you mean the temperature difference of the cold water? What did the cold water start at? Well, lab partner, think about it. The cold water came from the, oh, you know what? While I'm talking, this ice is melting. Hang on, lab partner. I'll be right back. You chill. Get it? It's funny. You chill because I'm putting this back in the freezer. You chill. So I was practicing. Patriots want me. They want me this year. The son of Michelle's got a hurt foot, so they need me. So I'm getting in shape for that. Where was I? I don't know. Where was I? Let's see. Okay, temperature difference of cold water. So where did the cold water come from? Well, and that's what reminded me to put the ice back. The cold water came from the ice. So you have an ice cube, and it melts, right? So the cold water came from the ice. And what was the temperature of the ice when it melted? So the ice melts at, you know this. Come on, Pepper. 0 degrees, thank you. 0 degrees, right? So the ice melts at 0 degrees. And what does it become at 0 degrees? It was solid at 0. Hopefully you've watched the videos. It's going to help you out with this. So it was solid at 0, melted, no temperature change during melting, becomes water at 0. So the cold water started at 0. And what temperature did the cold water end at? That's the equilibrium temperature. We had an equilibrium temperature between the hot water, 43.5, and the cold water, which is 0, and together they mixed and ended at 18.5. So what's the temperature difference of the cold water? It went from 0 to 18.5. So let's see, let's subtract 18.5 minus 0. This one we are going to need a calculator for. You'll get your calculator out and subtract those. What'd you get? 18.5? Okay. Oh, thank you, lab partner. 18.5 degrees is our temperature difference of the cold water as it went from 0 to 18.5, our equilibrium or finishing temperature. So write that down. Okay. Mass of the water after the ice melts. Okay, now this is where I got to do some sweet skills because I have to take, temperature now is beginning to rise a little bit, it's 18.7 because it's warm in the room, so it's warming up our water in the calorimeter, but at this point we don't care anymore because we've got our numbers. We're good. I have to carefully pour. This is where my skill comes in. I'm not good, you know, I'm not a good lab partner really. You're better than I am, lab partner. So I have to pour this back into the graduated cylinder and read the volumes to determine the mass of the ice. Because remember, we didn't mass the ice, did we? And we need to know the mass of the ice cube. And I didn't put it on a balance. So how are we going to get the mass of the ice? It's already melted. Exactly, it's melted. So now we have more water. And we started at 99.3 milliliters of water. And now I'm going to pour this back into the graduated cylinder, get the mass of the graduated cylinder by subtracting the new volume from the 99.3 from the new volume. Subtract those two, we get the mass of the ice. That must be where the water came from. It came from the melted ice. Okay, so let's do this. Enough talk. Pour carefully, or I screw this whole thing up. I've got to do it all over again. Okay, pour. Oh, I had coffee this morning. Not good, not good. shaky hands. Okay, I'm just going to stop there and record this number and write it down. We'll write it down. So let's see, that is meniscus that bad, Larry, there, 95.67, 97.8. I'm going 97.8, lab partner. So I'm writing that down, 97.8 milliliters, okay? So I'm going to get rid of this. And let's just double check that one more time, 98, 1, 2, that's 96, 97. No, 97.8, see? Good thing I double checked. Oh, I did write that down. I did write 97.8. I'm losing it here. And I had coffee too, that's the scary part. 1, 2, 97.8. Just triple checked it, 97.8. You check it, lab partner. You check. Okay. Okay, good. You concur. 97.8. All right, 97.8 it is. Let's pour that down the drain. Shake it out. Shake, shake, shake. Shake, shake, shake. Shake your booty. Shake your booty. Okay, I should write music. I got some really good lyrics. I gotta get my lyrics down so it seals my song. Okay, let's pour the rest of the water into the graduation carefully. Don't screw it up now. Okay, shake, 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 shake. And once again, shake your booty. All right, dump that all in. Let's read. Get down to eye level. I don't know if I can get back up. I'm getting too old for this. 21. Eyes as well. Not as good as they used to be. Not as good as yours, lab partner. 25. There's the 5. There's the 6. It's just below the 6. So I'm going to go 25.8. But you verify it, lab partner. Okay. Hold this up for you. 25.8. Okay, we'll double check it. 21, 2, 3, 4, 5. Maybe a little lower than that. I mean, maybe 25.6. I'm going to go 0.6. I'm changing it, lab partner. 25.6 with that meniscus, 25.6. Gotta read carefully, it's important. 25.6 milliliters. All right, you can now dump this out. All right. Oh, I'm gonna shut off the water. Some of you might hear it in the background going, "You're wasting water." I am, sorry. All right. So now let's take those two numbers and add those, and we'll get the total volume of the water and melted ice after we did the experiment. So adding those, it's 4, that's 12, that's 3, that's 9, 10, 11, 12. So I'm getting 123.4. What do you think, lab partner? So it's 14, let's check it again. 8, 13, 10, 11, 12. 123.4 milliliters is the total volume of the water and the melted ice cube. Now, we're not writing that in any spot there. What are we going to do with that? Okay, so I'm going to subtract the mass of the water, which was 99.3. So we're going to take that minus 99.3 milliliters. Of course, lab partners, you're doing this at home, and you're checking my work. Let's see who gets you on there. Okay, so there, those are the two numbers. We added them, got the total amount of water, subtract the amount and mass of the water by itself, and we'll get the mass of the ice cube. Yes, subtract those, get the mass of the ice cube. Whoa, good thing you're with me, lab partner. I appreciate you, checking up on me and making sure everything is on the up and up here. So this should be 23.4, 24.4, 24.1. 24.1 is what it should be. I'm doing that in my head. So 24.1. But let's just check it. Okay, add those up. Get 4, get 13, 2, 12. Yep, 24.1 milliliters is the mass of our water. 24.1 milliliters of the mass of the water after it melts. Mass of water after it melts. Well, actually, you know what? We can go ahead and the mass of the ice added, that's the last one, is 24.1. So 24.1. And actually, that 123.4 I just a minute ago said, well, we're not going to put that down anywhere. Well, we could actually put it in the data table. We don't have to, but we can put it in the data table above where it says, when I wrote mass of water after melts. That means the milliliters of the mass of the water after it's all melted. And we did get that with 123.4. So I'm going to go ahead and put that in 123.4 in that spot, the second to last spot. So here's what it looks like. So I did state earlier, I was mistaken. I didn't put a spot in the data table for it, but I did. I just forgot I did. Where are we? Here we go. So that's what we look like. So the mass of the water and the ice cube after it all melts, 123.4. Subtract those two, we get the mass of the ice cube as 24.1. All right, data table for trial 1 is now complete. We're going to do 2 trials. Remember, we said we would do 2 trials. So I'm going to put a line here, and we're going to put a set. You're going to have to write this in yourself, lab partner, for the second trial. Grams, Celsius, 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 grams and grams. So I'll go ahead and just put that in there. We're going to do trial 2. Now for trial 2, I'm going to use the more expensive calorimeter. We're going to lather, rinse, and repeat. Do the same thing that I did this time. So I'll be back in just a minute, getting you all ready for trial 2.